Hi everybody, I'm Josh Sprague and welcome back to another episode of Sinclair's Aviation video series. If you've ever looked in the cockpit of a plane and you've wondered what all the instruments do, what they mean, how they work, you're in luck because that's what we're going to talk about in today's video. We'll start on this side of the panel. This device here has a couple different functions. On the top of it, it gives you the outside air temperature in Fahrenheit as well as Celsius. Also has a voltmeter in there. Down below we have a clock which has four features. It has, right now it's on what would be like a stopwatch. There's also Greenwich time, which is based off the time in England that's used for navigation and sort of uniformity in aviation. The local time, and there's also a timer as well. To the right of that we have the airspeed indicator. It has several different markings on it for various operating ranges. This is for the flap operating range. The green is the normal operating range, the yellow is the caution range, and the red line is the never exceed speed. What we have here is an electronic or digital attitude indicator. Some airplanes that are used for training have all what we refer to as steam gauges, such as the airspeed indicator you saw a second ago. Others are all glass layouts where it's just one big display. What we have in this airplane is sort of a hybrid layout. This is the attitude indicator. It indicates blue sky, brown ground, turn degrees in 10 increments to start, 10, 20, 30 degrees, 45, and you can't see 90, and also 10 degrees and 20 degrees of pitch up. Here we have the altimeter. It is used to measure height above the mean sea level, which is not the height above ground, how high you are. It's the height above, as the name implies, sea level. So right now it's showing the airport elevation here. And the only time you would ever see this actually read 0 is if you were somewhere along the coast, maybe in Florida, the Carolinas, or somewhere in California. It's pressure sensitive, and you have to go through and pick up the current altimeter setting to adjust it properly. That's done by turning this knob. There's a window here on the right which is called the Colesman window, and that is what you use to set the pressure. Today the altimeter setting currently is 29.80 inches of mercury, and so that's sets us to the current airport elevation. Below the altimeter we have the vertical speed indicator, or VSI. It measures rates of climb or descent in 100 foot per minute increments. So for example, this is 500 feet a minute up, 1,000 feet, 1,500 feet, and 2,000 feet rate of climb, or if it's pointed down, descent per minute. Down here we have what looks kind of like a compass. It acts kind of like a compass, but it's not a compass at all. It's called a directional gyro, and it can be synced with the magnetic compass, which is on the dashboard, and it can be used for sort of aiding in headings and holding. The mag compass, as trusty as it is, sometimes is a little unreliable. It bounces around in there, so this is an easier way to see what heading you're flying and holding headings. And in this case, it actually gives you a digital readout of the current heading you're holding, which right now we're just a little bit north of west. We're at 276 degrees. Of course, 270 is a west heading. Down here, when I used to fly this airplane, I've got quite a bit of time in it. It didn't have the digital display. This is where the turn coordinator used to be. We'll get to that in a minute. This is a backup attitude indicator. It works much the same as the digital one does, with blue sky, brown ground, and the markings for the degrees of bank, as well as the climb and descent. Instruments over here have to do with various systems on the airplane. The upper left one here is the fuel quantity. It's the fuel gauge, just like you would have in your car. The Cessna 172 SP, which is the model we're in today, holds 26 gallons in each tank. Not all of that is usable. That's something you might talk about in your ground school if you come to train with us. To the right of that, we have these two here share one readout. This is the exhaust gas temperature. There's a yellow reference line there that when the airplane is in use, you try to want to keep the needle below. To the right of that, we have fuel flow. It's your gallons per hour on the plane. If I remember right, the 172 SP, if it's full rich, burns about 10 gallons an hour, but you can lean the mixture to get a little bit better fuel burn, and that's something we'll talk about in a future video. This is what's called an Omni Bearing Selector, or OBS. It is used to aid in navigation if you're navigating off of a ground-based system like a VOR or the instrument landing system. These needles come into play. If you're flying an ILS approach in your instrument training, you have the glide slope as well as the localizer guidance to allow you to fly the approach or navigate off of not only the ground-based systems but also the GPS as well. Down here is the turn coordinator. This is the only electrically driven device in what's referred to as the six-pack, which are some of the instruments you saw before. It's also been relocated, but when the wings are level, you're flying straight and level. These hash marks here on the left and the right side indicate 15 degrees of bank, which is referred to as a standard rate turn. And if you're maybe going to do instrument training, a little bit of a cheat here, you see it says 2 minutes. If you hold that 15-degree bank for 2 minutes, you will have completed a complete 360-degree circle and be back on the heading that you started on. You see the ball here. It indicates the coordination of flight. If it's completely between the two lines, or what we call caged, no matter what the flight situation, if you're straight and level or turning, it will allow it indicates that you're in coordinated flight. If the ball is outside the lines there, you're either in a slip or skid depending on the flight situation. Up here, this is just a control panel for the radio systems. The various settings. We have two communication, two navigation radios, and this just talks about which one is primary right now. You can switch it to the second one and put it on the speaker if you want.
2.10 Celsius. Altimeter 297.
That's the ASOS, which is the never-ending weather recording that is updated every minute or so here. Just below that, we have the GPS. This is what Q in the James Bond series might say he's particularly proud of. This is one of the most advanced tools in the airplane. I could take hours and go through everything that this has, but just for the easiest description, up here we have the communication radios, the active and the standby frequency. We also have the navigation radio, which ties into the OBS that we talked about before. Those are the frequencies that are plugged in there right now. The easiest thing I can show you to do is if you want to get the easiest heading to go to an airport or navigational aid, really a little bit of everything, you can plug that in here and it'll give you that information. I'm originally from Zanesville, so I'll use my hometown here as an example. Zulu Zulu Victor is Zanesville Municipal Airport. You hit enter. It asks if you want to activate it. You do that. And now what you have here is the map. We're at Wright Brothers Airport. The waypoint is Zanesville. The desired track to fly is 084, which is a little bit above flying east. We're 110 miles away. The ground speed is 0 because we're not moving, but you can zoom in to be closer to you, or you can zoom out if you want, and you can even clutter or declutter it so you can see only the airports, only the track, or you can get it to where you can see highways as well. There's Interstate 70, 75, 675. It's even picking up 71, which isn't too far away. Down here is our COM2 radio. It's for redundancy. Right now we've got the weather, the ASOS that you heard a few seconds ago in. It's also got a standby frequency. There's also another nav radio in here, as well as another timer if you needed to time a maneuver or a hold or something that you were doing. And finally down here we have the transponder. This is sort of a camera. It allows air traffic control to track where we are. What you can do is, if you're flying just in sparsely populated airspace, you'll use the code 1200, which is VFR, or if you're going into controlled airspace, or if you want air traffic control to keep an eye on you, you can plug in a 4-digit code that they'll assign, and then when air traffic control gives that to you, you can hit ident, which will mean you flash on their radar. They'll see you, and then they'll know that that's who you are. And you've got the flight ID, which is the registration of the plane, November 88 Juliet Alpha. Just a quick thing about airplane registrations. This is kind of like the license plate for the plane. All of them in the U.S. start with N and then an alphanumeric code. The numbers come first, and then the letters, and it's no more than 5 characters, of which no more than 2 can be letters. So that just allows ATC to keep track of where we are and help with traffic avoidance and just general situational awareness.